In this video, we're going to be factoring a quadratic that has real solutions. And when I say real solutions, I just mean that it crosses the x-axis. In other words, we have x-intercepts. And to demonstrate that, before we even go through and we solve this, I'm going to go ahead and just show you right quick. If, for instance, I put up my graph and feature in my calculator, and I typed in x squared plus 2x minus 35. And I hit graph, right? You can clearly see that my graph just crossed a point right here, and it crossed a point right here. Now, if I counted my bars right over, that looks like that's at 1, 2, 3, 4, 5, 6, 7. It crossed at -7. And then it crossed over here at 1, 2, 3, 4, 5, at +5. So, respectively, we have x is equal to -7. That's one of my zeros. And I have x equals +5. Now these are my zeros. We also call our zeros, we have a few different names for them, and one is it's our solution. We also like to call it our roots. And we can also call it our x-intercepts. So they're all the same thing. If I wanted to turn these into factors, right, because we're actually being called to factor this, I could just change the sign on these two, because this is a very simple problem, and I would end up with something like x plus 7 times x minus 5. And this is a trick that most of you, your teacher probably taught you in Algebra 1, is you could find the zeros, and if you wanted to check to see if you factor something properly, once you found the zeros, you can just change the sign on it, and you have your factors. But let's refresh your memory on how we factor to get a real solution. Now, the first thing I want to do is when I come over here, we're looking at this, and this is in the form of ax squared plus bx plus c. So just remember that, right? When you learn this, you learned that this was ax squared plus bx plus c. And this is important because I'm going to be talking about these terms, and each letter represents a number that's in front of either these first two variables or is your constant value, that c value. Now, you do need to remember that there's always that invisible 1 in front of every variable that doesn't have a number. So there's actually a 1 in front of the x right there. And what I want to do, starting off, is I'm going to make a number tree. Now, you probably haven't done those since 7th grade, unless your algebra teacher was like me and had you do number trees to help you find the factors of your term c. So I'm going to circle c. -35, this is where I'm going to start, and I always start this whenever I see I have a coefficient of 1 in my leading term. I go straight to c, and I'll try to determine, well, what are my factors for c? So I'm going to find my factors, and I'm looking for the factors of 35. I'm not worried about the negative sign, I'm just saying the number 35. And when I say factors, in other words, what numbers can divide into 35 equally? Or you could look at it as what two numbers multiply to give me 35. And for instance, I could say, well, you know what, 1 times 35 will give me 35. And then I'm going to go to the next one. So, well, what about 2? And if you're not sure if 2 can multiply to anything and give you 35, what I found to be the easiest way, again, if you're like me, you don't memorize all your math times tables and whatnot, it's difficult for you, is you just start dividing. So 1 is our first number. We already know 1 times 35 is 35. So I'm going to take 35 and divide it by 2. Now notice that gives me a decimal value, so 2 doesn't work, so we're going to skip 2. We're going to go to the next number after 2, which is 3. So we're just, if you can count from 1 to 10, then you can do this very easily. And so I'm going to say, well, 35 divided by 3. And notice it doesn't work. I get a decimal strand again. Okay, well, what comes after 3? 4 comes after 3. So I'm going to do 35 divided by 4. And it gives me 8.75, so that didn't work. So we're going to go to the next one. Our next number is 5. So we'll do 35 divided by 5. And notice it gives me 7. So that's going to be my next factor. It's going to be 5 and 7. And the only number left that I can check that might be a factor of 35 would be the number that's in between 5 and 7. So what comes in between 5 and 7? And it would be 6. So if you're not sure if 6 will work, we can throw it in there and just see if it works. And it does not. It gives us a decimal strand. So these are all of our factors. We can actually stop here. And if you're wondering why we can stop, it's because after 5 is 6, and we verified that 6 wouldn't work. And after 6 is 7, and 7 is already here. So there's no point in writing 7 over here when you already have a 7. Therefore, these are all of our factors. So if you use this factor tree method and you just think about it as, I'm going to continue to divide a number until I find something that goes into it equally, until I'm out of numbers, then it's a very fast way, an efficient way to get all your factors so that you can determine which one of them will be put together to give you the b value. Because what we're looking for, technically, is we want to know two numbers that multiply to give us 35, and we want to find two numbers that will combine to give us 2. Now, the way I figure out on the combining is I have an approach to that too. I just simply add and subtract these two values. And I usually start by adding. In other words, I say, well, 1 plus 35 would give me 36. And just for those who want to see the numbers in here, 1 plus 35 gives me 36. And 36 is not what we're looking for. We're looking for a b value of positive 2. So I'm trying to get a 2. So then I can say, well, you know what? Let's subtract them. Instead of adding them, let's subtract them. Well, 1 minus 35. And that gives me 34. So that's not going to work. So I can already scratch out these two top ones and eliminate them. My factors cannot be 1 and 35, because with 1 and 35, I'm either going to get 36 or 34. So now I'm going to try to get a 2 out of a 5 and a 7. So first, I'll start by adding them. 5 plus 7. It gives me 12, and that's not what we want. We want a 2. So now I'm going to subtract it. 5 minus 7. And notice I can get a 2 when I subtract 5 and 7. So I'm going to circle these because we're almost done. The next thing that I want to do is I want to look and see, is my 2 a positive 2 or a negative 2? And it happens to be a positive. How do I know that? Because there's a positive sign in front of this term right here. So I'm looking for positive 2. Now, if I want my 2 to be positive, I can continue to play with the numbers in the calculator in the guess and check method if you can't do this in your head, and just figure out how can I add or subtract 5 and 7 to be able to get a 2. Now, I did get a 2 here, but it was negative, so that's not going to work. So what I'm going to do is I'm going to switch it. Instead of doing 5 minus 7, I'm going to try 7 minus 5. And notice that does give me positive 2. So what that tells me is my 7 has to be positive and my 5 has to be negative. So I'm going to write the signs beside it. My 7 has to be positive and my 5 has to be negative. And now that I got my two terms that multiply to give me negative 35 and that combine together to give me positive 2, I'm ready to write my factors out. My factors are simply going to be x and put another x. And I'll always start with the number on the left first. So it'll be x minus 5 and then x plus 7. And I'll box it, and that is my answer. I have found the factors for this quadratic. Now, we had already found it another way, right? Earlier, I showed that we could just graph it and look for the zeros and change the sign. But this over here on the left is the proper way to do it mathematically without looking at a graph. You would want to go ahead and find the two numbers that multiply to give you C and the two numbers that combine to give you your B value. I am going to go ahead and just show you with the calculator and just verify it. If I do negative 5 times positive 7, it gives me negative 35. Now if I do negative 5 plus 7, it gives me positive 2. And that's how you factor a quadratic that has real solutions. Now I'll go to my next video to see how to do one that has complex solutions.